You know, in the world of AI, there's been this one simple rule that everyone's been following for years. Bigger is always better. But what if that's not the whole story? What if the real future of AI is actually small? Right now, if you look at the playbook for building powerful AI, it's shockingly simple. This is especially true when we talk about AI agents, the systems that are designed to actually do things for us. The entire industry, it seems, is following one very, very simple rule.
That's it, seriously. The wisdom has been, if you want more intelligence, more capability, more of everything, you just build a bigger model. More parameters, more data, more compute power. But hang on a second, is that really the smartest way to go?
We are smack in the middle of a revolution with what people are calling agentic AI. These are the systems that don't just answer your questions, they take action. They book your appointments, they write code for you, they manage entire workflows, and right now, pretty much all of them are powered by the absolute largest, most expensive models on the planet. The brains behind the operation for these agents, it's almost always one of these massive, general-purpose large language models, or LLMs. A good way to think about it is like this. Your agent is a car, and the LLM is its engine, a huge, powerful, one-size-fits-all V12 engine. In this whole bigger is better philosophy, it's not just a theory. It is backed by an absolutely colossal amount of money. We're talking an estimated $57 billion that's been poured into the cloud infrastructure just to host and run these giant models. The industry has placed a massive bet on this single approach.
And this brings us to the most important question in this whole discussion. Think about what these AI agents actually do most of the time. It's specific, often really repetitive tasks. So, do you really need a super genius engine that can write poetry and debate philosophy just to make the same API call over and over again? Could this be a massive misallocation of resources?
Well, that's where this fascinating new paper comes in. It's making a bold, totally counterintuitive bet against the way things are going, arguing that the industry's obsession with size is just a fundamental mistake.
Instead, the paper argues that the future of agentic AI belongs to their smaller, nimbler cousins, small language models, or SLMs. And their entire argument really boils down to three powerful claims.
First, and this one might surprise you, they argue that for the specific jobs these agents do, small models are already powerful enough. You simply don't need a sledgehammer to crack a nut.
Second, it's not just that they're powerful enough, they're actually more suitable. They're a better fit for the job. It's about using the right tool, a scalpel for surgery, not that sledgehammer.
And third, and this is the one that should get every developer and business leader's attention, they are way more economical. And I'm not talking about a little bit, I mean a lot. This isn't just an interesting engineering debate, it's a powerful business case. Okay, so those are some pretty bold claims. What's the evidence? Why are these researchers so convinced that small is the new big? Let's break down their case. So, the paper's first big argument is a direct challenge to the old scaling laws, that idea that a model's performance is tied directly to its size. They're saying, nope, not anymore. With all the advanced techniques we have today, what really matters is a model's actual capability on a specific task, not its raw parameter count. We've just gotten a lot better at unlocking the hidden potential of smaller models.
And this isn't just a theory, we've got the receipts. You have models like Salesforce's XLAM, with only 8 billion parameters, outperforming giants like GPT-4o on tool calling. You have Toolformer, which is even smaller, beating the 175 billion parameter GPT-3. The data is clear. For these specific, agent-like tasks, specialized skill is now beating generalized size.
So, what does this actually mean in practice? Well, beyond just performance, small models have these huge practical advantages. They're dramatically cheaper, they're faster, we're talking real-time responses, and they're way more flexible. You can fine-tune one overnight. Plus, you can deploy them anywhere, from the cloud all the way down to your own device.
And let's put a hard number on that economic advantage. According to the research, serving a 7 billion parameter SLM is between 10 and 30 times cheaper across the board in speed and energy in pure computation than a typical big LLM. That is an absolutely game-changing difference in cost.
Now, this doesn't mean we just throw the big models out entirely. The paper isn't arguing from an SLM-only world. Instead, it's proposing a much smarter, more sophisticated hybrid approach.
The idea is what they call a heterogeneous agentic system. The best way to think of it is like a team. The small models are your efficient, specialized workhorses, handling the vast majority of tasks. And the giant language model?
That's the expensive, expert consultant that you call in only for the truly complex problems that the specialists can't solve on their own.
And here's the really cool part. This isn't just some far-off idea. The paper actually lays out a clear, practical roadmap for developers to migrate their agents to this smarter, hybrid system right now. Let's walk through the steps. They call it the LLM to SLM conversion algorithm, and it's a 6-step loop. First, you just log all the conversations your agent is having with its big LLM brain. Then, you clean and cluster that data to find recurring tasks. For each of those tasks, you pick a good SLM candidate, you fine-tune it on your own data to create a cheap, fast little expert, and then you just keep iterating. It's a continuous cycle that makes your agent smarter, faster, and cheaper over time.
So, this all leaves us with a really fascinating question for the future of AI. Is it going to continue to be dominated by a few massive monolithic models built by a handful of companies? Or are we heading towards a more democratized, more efficient ecosystem, a smart swarm of specialized models all working together? Based on this research, the smart money just might be on the swarm.